Hello class, welcome to lesson 6.2, which is all about substitution. By the end of this lesson, you should be able to solve systems of equations by using substitution, and you should be able to solve real-world problems involving systems of equations by using substitution. This is going to be nice for a lot of you because a lot of you really dislike graphing, so this is a way to solve systems of equations without having to graph. Okay, so solving by substitution, this is something that you maybe want to take a screenshot of and add to your math folder. It goes through the 3 steps for solving by substitution. So the first thing that you want to do is you want to solve for at least one equation, for one variable. That means you want to have one equation that says y equals something, or you want to have an x equals something. Okay. The second step is then to substitute that equation from step 1 into the other equation, which I'll show you what that looks like. And then step 3, you solve for one variable, you plug that back in to find the other variable, and you write your solution as an ordered pair. Okay, so let's try this out. Step 1, solve one of the equations for a single variable. Well, if we look, we have a y equals already. So our step 1 is done. Since we have a y equals, we know what y equals, well, that means we can plug it in right here. So what that looks like is I do 5x plus 3, 4x minus 6 equals -1. Okay, so I took that whole equation, because that's what y equals, and I plugged it in for y. Now from there, I want to distribute and get rid of my parentheses. So now I have 5x plus 3 times 4x is 12x. 3 times the -6 is -18 equals -1. I'm going to go ahead and combine some like terms to make it a little neater. So I have 17x minus 18 equals -1. And then if I go ahead, I can tee it up. I can start moving things to the other side of the equal sign. So I want to get x by itself, so I'm going to move that 18. So I have 17x equals -1 plus 18 is 17. Okay. So if I tee it up again, I divide both sides by 17, and I have x equals 1. Okay. So I now know what x equals. So the awesome part of that is I just have to plug x equals 1 into one of the equations. So I can say y equals 4 times 1 minus 6, or y, 4 times 1 is just 4, 4 minus 6 is -2. Okay. I now know what x equals, and I know what y equals, so I write it as an ordered pair. 1, -2. That is how you solve by substitution. Okay, so let's try another one. Maybe that first one didn't make sense. That's okay. That's why we do multiple examples. That's why you ask questions. Okay, you're in school to learn. So now, step 1, solve for one of the equations for one variable. That's already done for us again because we have a y equals. Should you ever have an x equals, that's also okay. You just plug it in where you have an x. Okay, so we have 2x plus 5, and then throw in my parentheses, and everything that y equals goes inside of those parentheses. And again, it equals -1. So first step, or next step, get rid of my parentheses. So I have 2x plus 15x plus 50 equals -1. Clean it up a little bit by combining like terms. I have 17x plus 50 equals -1. If I tee it up, I can get 17x by itself by subtracting 50 from both sides. So I have 17x equals -51. If I tee it up again and divide both sides by 17, I have x equals -3. I now know what x equals, so I go ahead and plug that in to one of my equations. So I say y equals 3 times negative 3 plus 10. Ooh, that was a terrible 10. You may be wondering, do you have to use the y equals? Could you use the other equation? You can use either of the equations that you were originally given. That's fine. I'm just using the y equals because we have y equals, and that's what I want. I want to know what y equals. Okay? But if you were to use the top equation, you would ultimately get the same answer. So we have y equals 3 times negative 3. That's negative 9 plus 10. So y equals 1. So I go and I write my solution. I look, what does x equal? X equals negative 3. Y equals 1. I write it as an ordered pair, and I am done. See if you can solve this system of equations on your own. Hopefully you ended up with 1, 2. If not, be sure to ask for some help, whether it's a friend or myself. Let's look at example 2. Let's try again. We want to use substitution to solve the systems of equations. This time, we don't have a y equals or an x equals. So that means we have to do that ourselves. So what I suggest you look for is you look for which equation has a variable that doesn't have a number with it. So if I look, I have 3x, x has a 3 with it, 5y, y has 5 with it, y has a negative 2, but right here, I already have an x that doesn't have a number. So what I'm going to do is I'm going to solve this equation for x. So that means I need to get x by itself. The way I'm going to do that, I'm going to add 2y to both sides. So I have x equals 2y minus 3. Okay? If you wanted to solve for y or any of the other x's or the other x, that's also okay. All right? So now I have x equals 2y minus 3. So I'm going to take that and plug it in right here where I just drew a scribble. All right, so I have 3 times 2y minus 3 plus 5y equals 24. Again, I get rid of the parentheses right away. So I have 6y minus 9 plus 5y equals 24. If I keep going and combine some like terms, I have 11y minus 9 equals 24. If I tee it up and I add 9 to both sides, I have 11y equals 33. And if you need to, tee it up again, divide by 11. I have y equals 3. Now I take my y equals 3 and I plug it back into my x equals equation. So I have x equals 2 times 3 minus 3, or 6 minus 3, which is 3. I finish by writing my ordered pair. My x value is 3, my y value is 3. All right. And then let's continue. Go ahead and try this next one on your own, see how you do. Hopefully you said the answer is letter A, negative 2, 6. If you have questions about that, be sure to ask. Let's look at example 3. We want to, yet again, use substitution to solve each systems of equations. So I look at 3a, I see I have a y equals. Cool. That means I just have to plug that in to my equation. So I plug the 2x minus 3. Make sure you don't forget, even though there's not a number right here, don't forget to do the parentheses because we have to distribute that negative. So this is 2x, and then negative, that's like a negative 1. Remember, 1 has invisibility superpowers. So if we distribute that, that's minus 2x. and that becomes a positive 3, okay? That's a super easy mistake to make. It's really easy to want to go really fast and just be done, but that will end up very badly. So if I combine like terms, 2x minus 2x, those cancel out. I'm left with 3 equals 8. Uh-oh. That's not true. So what happens when we end up with a statement that's not true? We say no solution. That means these two lines are parallel, remember? Just like we talked about yesterday, when there's no solution, that means you have two lines that are parallel, okay? Let's look at letter B. If we have 4x minus 3y equals 1, and we have 6y minus 8x equals negative 2, the first thing I'm going to do is rewrite it so that these x's and y's are vertical with each other because it makes life easier. Okay, it's good practice for what's coming tomorrow. So now let's look, what should I do? If I look at that 4x minus 3y equals 1, and I have a negative 8x plus 6y equals negative 2, something that I see is you might immediately think no solution, or you might try solving it, solving for a variable, and that's fine. But I would encourage you guys, let's see if you can figure out how are these two equations related. How do I get from a 1 to a negative 2? How do I get from a negative 3 to a positive 6? How do I get from a 4 to a negative 8? Well, to get from 1 to negative 2, I'm either going to subtract 3 or multiply by negative 2. To get from negative 3 to a positive 6, I'm either going to add 9 or multiply by negative 2. To get from 4 to negative 8, I'm either going to subtract 12 or multiply by negative 2. So notice you can multiply all of these numbers by negative 2 and end up with that second equation. What that means, whenever you can do that, whether it's multiplying by negative 2, no matter what, if you're multiplying by the same number every time to get to the next equation, that is infinitely many solutions. That means that those two equations will give you the same line. So check to see, is there any way that these equations are related? That's a good thing to check right away before you even start moving anything. Go ahead and try this first one on your own. Hopefully you determine that this one is also infinitely many solutions, because if you multiply everything by a negative 2, you get to the second equation. All right, let's look at our final example together. We're talking about a music store that sold a total of 125 car stereo systems and speakers in 1 week. The stereo systems sold for $104.95, and the speakers sold for $18.95. The sales from these two items totaled $6,926.75. How many of each item were sold? Okay, so this can be a little tricky to figure out how do I write my equations for this, because equations, plural, because we're talking about systems of equations in this chapter. So the first thing we are going to do, a music store sold a total of 125 car stereo systems and speakers. Okay? I'm going to call this X and this Y. Put together, I sold 125 of my car stereo systems and speakers. So if I look at that, I'm actually going to move that a little closer. If I look at that, that is my first equation. As simple as that. It usually gives you how many of something were sold, and that's going to be something plus something, or something minus something equals a number they give you. Okay? Then, if we look, I didn't mean to make that so small. What is our next equation going to be? Well, if stereo systems, okay, I said that was going to be X, sold for $104.95. If I take $104.95 and I say X, that means if I sold 2 of them, it's going to multiply that price by 2. If I sold 5, it'll multiply by 5. Okay, you guys are familiar with this concept. We've been doing it for a long time. Speakers sold for $18.95. We said speakers were Y. So however many speakers we sold. And we know our total money was $6,926.75. So those are my 2 equations. That is possibly the most difficult part of this entire process, because now we know what our 2 equations are, and we've already been practicing today how to solve these. So if we want to figure out how many of each were sold, that means we have to solve for one of the equations. So if I solve this first one for X, I say X equals 125 minus Y. That means I have to plug that in. So I have 104.95 times 125 minus Y. Let me move it up a little bit just to make it easier for me to write. Plus 1895Y equals 6,926.75. So if I distribute and get rid of my parentheses, I'm left with 13,118.75 minus 104.95Y plus 1895Y equals our total. If I go ahead and combine some like terms, I have 13,118.75 minus 86Y equals our total. If I keep going and I move the 13,118.75, if I subtract that, I'm left with negative 86Y equals, and that is negative 6,192. If I divide both sides by what? Negative 86. I'm left with Y equals 72. So that means I sold 72. What does Y stand for? Speakers. Okay, so 72 speakers. And I sold how many stereo systems then? Well, I know I sold 125 items total. So if I sold 72 speakers, that means I sold 53 stereos. And that would be my answer for this problem. Go ahead and try this problem on your own. If you need help, be sure to ask in class, okay? Alright, hopefully you said 5 milliliters of the 10% solution and 5 milliliters of the 40% solution. If you have any questions on anything from this section, be sure to ask. Have a fantastic day.